Okay. Now, when we have a decimal in the divisor, it gets a little bit more complicated to do our division. So if I have 12 divided by 6/10, okay, I need to do something to make this 6/10 a whole number, but not change the answer to the problem, okay? And so whatever I do to this number, I also have to do to this number in order to keep my problem true. So let's talk about a couple of things. So first of all, 6/10, okay? To make that into a whole number, I can multiply it by 10. Okay, and you should have seen that happen in the first slide or the warm-up that you did on this slideshow. Because when I multiply by 10, what happens is it shifts the place value of all of my numbers over once, which changes the placement of the decimal, essentially. And so it moves the decimal over, and we would get 6. So 6/10 times 10 is equal to 6, okay? Now, I can't just do that to the 6/10. I also have to do it, which is my divisor, I also have to do it to my dividend. Okay, and let's look at proving that that works. So if I'm going to pick completely different numbers. If I have 20 divided by 5, that equals 4. Okay, now if I multiply my dividend and my divisor both by 10, I would get 250. So I would get 200 divided by 50, which guess what? That still equals 4. Okay, if I did it again, if I multiplied it by both of them by 10 again, and I had 2,000 divided by 500, guess what? Still 4. Okay, so when I multiply both my dividend and my divisor by the same factor, my quotient does not change. Because essentially what I've done is I've multiplied by what my professors called a foo, a form of 1. Because you're basically multiplying them by 10 over 10. And 10 divided by 10 is just equal to 1. And when we multiply the number times 1, it stays the same. Okay? So whatever I do to one part of my division problem, I need to do to the other part of my division problem. If I were to do 200 divided by 5, which would be multiplying only the 20 by 10 and not the 5, this would be 40. Okay, if I did it the other way and I did 20 divided by 50, this would actually be equal to 4/10. So if you only multiply one of them by 10, then you would end up your answer would be off by a power of 10. Okay? So this also works by multiplying by 100. So if it were necessary to move the decimal point twice to get a whole number, you would multiply both numbers by 100. You would move the decimal twice. Okay, so that's a lot. But if we're looking at this problem, if we have 12 divided by 6/10, okay, I want the 6/10 to become a whole number, and I do that by multiplying by 10, which moves the decimal point over once. Okay, so I'm going to get rid of this here. Okay, and if I do that to the 6/10, the divisor, I also need to multiply the dividend by 100. In this case, the 12 has a decimal point at the end, and so I move the decimal point over one space to the right, which means I have to annex a 0 or put a 0 in place in that empty place. Okay, now we just have 120 divided by 6. So 6 can go to 12 twice. I subtract the 12. I get 0, I bring down to 0, 6 goes into 0, 0 times. My answer is 20. Okay, so if we have a decimal in the divisor, we have to move it over until we have a whole number, and we move the decimal over in the dividend the same number of times so that our answer remains the same.